Welcome students, in this video we will learn derivative of trigonometric functions. So there are some formulas of trigonometric functions which you need to learn. The derivative of sine function is cos and derivative of cos is minus sine. Derivative of tan is secant square, derivative of cot is minus cosecant square, and the derivative of secant is secant x tan x, and derivative of cosecant x is minus cosecant cot x. Now let's take an example to understand how to use these formulas. So here we need to find the derivative of x sine of x. So if you notice that there are two functions, so we use the product rule where x is first function and sine of x is second function. So according to the rule, first function as it is and derivative of second function. So derivative of sine is cos of x plus the second function sine as it is and the derivative of x which is 1, and then simplify. This is your final answer. Another example is we have to take the derivative of this where two functions are dividing. So obviously we use the quotient rule, and according to the quotient rule, we take the square of the denominator term, which will be 1 plus x square, and the same term will be on the numerator, and the derivative of the numerator term, which is sine of x, whose derivative will be cos of x, and then minus the numerator term as it is, and the derivative of denominator function, which will be 1 derivative is 0 and cos derivative is minus sine of x. Now it's time to simplify, which will be cos of x plus cos square x minus sine x come plus. So 1 plus cos square, same on the denominator. As you know, the trigonometric identity, that's cos square plus sine square is equal to 1. So this term would be 1. And you have cos of x plus 1. And I'm going to rearrange the denominator because it looked like the same on the numerator. So cos of x plus 1 square. And one term will be cancelled out and you will left as 1 plus cos x plus 1. That is your answer. Okay, here is another term which you need to find the derivative of just secant x, which is not difficult. But here we need to take the double derivative because it's f double dash. So the function is f of x is secant x, and as we know that the derivative of secant x is secant x tan x. So f dash of x is equal to secant x tan x. This is the first derivative, and now we need to take the derivative again. So f double dash of x will be the derivative of these two. Here two functions are multiplying, so we use the product rule. First function as it is and the derivative of tan of x, which is secant square x, plus the second function as it is tan of x and the derivative of secant x, which is secant x tan x. And now simplify, which is secant cube x plus secant x tan square x. And in the question we have to find f double dash pi by 4. All you have to do is you have to replace x with pi by 4 in this function and get the answer. This is your task to do. Here is another trigonometric function for which we need to take the derivative, and obviously the function is dividing, so we use the quotient rule. So according to the rule, we have 1 plus tan x as a square on the denominator and the same function on the numerator, and the derivative of secant x, which will be secant x tan x, and minus the secant x as it is and derivative of 1 plus tan, so 1 derivative is 0 and the tan x derivative is secant square x. Now we need to simplify. So when we simplify, secant x tan x plus secant x tan x square minus secant cube x. And if you notice that we can take the secant x common from the numerator term. Now we can simplify tan square x minus secant square. So as you know that the trigonometric identity is 1 plus tan square is equal to secant square. So as we need to find tan square x minus secant square, so we take the secant square on the other side and 1 on the other side. So it will be tan square x minus secant square x is equal to negative 1. So in this place we will plug negative 1 and you have tan of x minus 1 with the secant x, and denominator is the same. This is your final answer. Sometimes you have this type of functions. So how could we solve? So before using the quotient rule directly, first you need to simplify this. And you know that secant x here is can be write as 1 over cos of x and denominator is the same. So it will become sin x over cos of x. And you know that the sin x and cos of x is equal to tan of x, tan x over 1 plus x tan of x. Now we can apply the quotient rule on this same according to the rule 1 plus x tan of x square and denominator function as it is on above and the derivative of numerator term which is secant square x minus the tan of x as it is and the derivative of denominator term. So in denominator we have 1, derivative 1 is 0, but the second term is you again two functions are multiplying. So we apply the product rule for this term. And in this term you have x tan of x. So x as it is and derivative of tan of x which is secant square plus tan of x as it is and derivative of x is 1. So when we simplify, we have 1 times secant square is secant square plus x tan of x secant square and minus tan of x multiply will be inside terms. Same term would be cancelled out and we're left with secant square minus tan of x square 1 plus x tan of x. According to the trigonometric identity which we have 1 plus tan square of x is equal to secant square of x. So here we take tan square on the other side, so it will be secant square of x minus tan square of x is equal to 1. So plug 1 in this place and we left as 1 over 1 plus x tan of x square. This is your answer. Now we have another type of questions and same before applying the quotient rule directly we need to simplify. So if you notice that there are some trigonometric functions and some algebraic function as well. So we'll separate that as a first function and second function. So on the numerator you have cot of x. So we try to make the cot of x on the denominator where you have cos of x and cosecant which can be write as 1 over sin of x. And this would become cot x 3 minus cot of x. Now we can apply the quotient rule for the second part. So first we apply the product rule and after that we apply the quotient rule on this part as well. First of all we need to apply the product rule on the both terms. So first term as it is and the derivative of this whole fraction term plus this fraction term cot of x over 3 minus cot of x as it is and the derivative of the first term which is 2x plus 0. Now simplify this x square plus 1 will be as it is and derivative of this term and here we apply the quotient rule. According to the quotient rule 3 minus cot of x square as it is and 3 minus cot x in the numerator and the derivative of numerator term cot of x whose derivative is minus cosecant square. The minus numerator term cot of x as it is and the denominator term derivative is 0 and the derivative of cot is minus, so minus minus become plus. And now plus multiply the second parts 2x multiply with this term, so it will be 2x over 3 minus cot of x multiplying with cot of x. And now it's time to simplify. The numerator terms will be simplified this way. And here you notice that the same term will be cancelled out and your left is minus 3 cosecant square x minus cot of x with the denominator 3 cot of x square plus the second factor as it is here. And we cannot simplify it further and because we got the derivative of the function. Thank you so much for watching. Please subscribe my channel for more videos.